Hey everyone, welcome back. So today we'll be solving online stock span. This is a medium question and I'll be solving it in Java, but the concept is going to remain the same. And I've not solved this question actually. The thing is I've attempted it, and but it threw me an error. I'm going to be doing something different other than what other YouTubers do. Uh, the thing that I figured out is that whenever I'm solving a problem, I get stuck at a point, right? Now, I would want to know how another person who solved the problem got over that point, right? So, that is the reason I'm recording the complete video of me understanding the problem, doing the problem on the uh, video itself. Okay, it's not that I'm going to do it pre before and then record it and then post it, right? I want to do it so that you guys understand, okay, where I'm getting stuck and how I'm getting over it. Okay, I might find the solution, I might not, but let's try to figure it out. Okay, I have to find the solution anyways, right? Perfect. So the question says that you're given an array of not an array, you're given certain operations, that is a stock spanner. This is where you initialize, right? And initialize the object of the class stock spanner, right? And then you have next, you have the function next. So what is this next? So the thing is, next is a stock on the idea, right? So whenever you give in next, what I need to do is I need to return the number of stocks that is lesser than or equal to that is lesser than or equal to that is lesser than or equal to the current element. For example, if we take 70, how many elements? Okay, how many elements are lesser than or equal to 70? It's 60, right? For 60, how many elements are lesser than or equal to 60? 60. So there is one element, right? But tell me something. Is this a like, can I include this 60? No, because the question says the consecutive elements lesser than or equal to the current element, right? Okay. Now I need to figure out for each next. I need to figure out, for example, if we take 75, consecutive element that is lesser than or equal to 75. I need to figure out. Okay. Now, and so also one thing I need to do is, if I'm having 75, there is 1 2 3 elements lesser than 75. But if you see, my answer is 4. Why 4? Because you also included 75. So the question is saying, give me the elements lesser than or equal to 75 including 75. So you'll have 4 elements, right? Let's look for this example, 85, right? 85, you have 1 2 3 4 5 5 elements lesser than 85. Then you have sixth element, which is sixth element is nothing but 85. So in total you have 6 elements. Okay, so let me take this example. Okay, so I mean, it's not going to be an array, right? So it is an input again and again, as in like you'll be given next and need to store it somewhere, right? So but for just figuring out sake, let me have it like this: 100 80 60 70 60 95 and 85, right? Now my answer for this is 1, right? Because there are no elements. This also 1, this also 1, this is 2, this is 1, this is 1 2 3 4, this is 6. Right? Okay, let's try to find the approach. Okay, now okay, see, when I look at this, what I can say, for 70, right? What are the elements lesser than 70? It's only 60, right? It's only 60. Okay, and for 75, what are the elements lesser than 75? It is nothing but 60, right? So 1 2 3 4, 4 elements, right? Now tell me something. Whenever I have an element, let's say I've stored this, right? Let's say my array only contains 100 80 60 70 60 and then this is my array, right? Now I'm trying to add 75. while adding, I need to figure out the count of all the elements lesser than or equal to 75, including 75, right? When I have 75 over here, right, all the elements lesser than 75 I need to figure out all the consecutive elements. So can I say that I will be iterating through the element until I find an element greater than 75, right? So I'll be going through the elements downwards until I find an element greater than 75, right? Perfect. In other words, can I say that whenever I'm inserting 75, right, I'm finding the element from right to left. I'm finding the element from right to left, which is the nearest greatest, right? For 75, I'm finding the element which is the nearest greatest. What is the nearest greatest of 75? It is 80. What is the nearest greatest of 80? Is 85, it is 80. Nearest greatest of 70, it is 80, right? Perfect. So what I'm trying to find, for every element, right, if my 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 top element is less than the current element, I'm trying to find next greatest element from right to left. Okay, now you can ask me, Siddharth, how will you do this, right? How will you do this, right? So how do you find nearest greatest elements to from right to left, right? If you're given the array, right, and you're given like already you're given an input array of 100, 80, 60, 70, 60, 75. Okay, how will you find the nearest greatest element, right? What will you do? You would ideally have a stack, right? You would ideally have a stack, and in this stack you would put the elements, right? So you would put 75 and then you would mark it as -1 because there's no element currently which is greater than or equal to 75, right? Now then you have 60, right? For 60 you need to find the elements that is greater than or equal to 75, right? So for 60, towards the left, right? Okay, my bad, I wouldn't be doing it from right to left, I'd be doing it from left to right, right? 100, 80, 60, okay, same way. So I'll have a stack, right? In this stack, what I'll be doing, so I'm trying to find the greatest element, right? So for 100, is there any element greater? No. So I put in 100. Okay, then I put in -1. Then I encountered 80, right? Is an element greater towards left? Yes, 100 is greater. So I put in 1, right? For 60, what will you do? Is an element greater? Then I put 80, right? Okay, then I got 60. Okay, this is 0, 1, 2, 3, 4, 5, right? 60, I'll put in 2. I put in 60, right? Then comes 70, right? I'm trying to find the element greater than 60, right? If I found 70, can I remove 60? Because I know for a fact if I found 70, right, 60 is never going to be my nearest greatest element, right? So I can put in 70. Okay, this 70, this will have index of 1, right? And then I found 60, the nearest greatest element is 70. I put in 70, right? This is 70, that is the index 3. So I put in 60, right? Now I encountered 75. Okay, so what I do is I pop this out, and then I pop this out because these cannot be my nearest greatest element, right? Okay, then I found 85. Okay, I found 85. The address of 85 is 1, right? So then I put in 75. this is how I would do, right? So what I've done, the nearest greatest element of 75 is at index 1. I found that out. Perfect, perfect. Okay. Now, this is somewhat similar to what we're trying to do. Okay. Now let's take the example of the input array again. That is 100, 80, 60, 70, 60, 75, 85. Okay. Now, what I'm gonna do, I'll try to apply the same approach in a little bit different way. Okay, I need to know what are the elements that is downwards greater than or equal to the current element. Okay, let's just see that. So what I'm saying is, okay, this is my stack, right? So I have it. Okay, now what I'm gonna do is, okay, I have 100, right? What I'm gonna do is I'm gonna put 100 in my answer. I'm gonna have 1. Okay. Now what I'll do is I'll do one more thing. Okay, I'll try to say how many elements are greater than or equal to how many elements are less than or equal to 100. There's only one element, so I'll include that element as well. Perfect. Okay, now I come to 80. Okay, I need to see how many elements are greater than or equal to 8, less than or equal to 80. Now I'm going to see the top of my stack. I found 100, so I know for a fact 100 is greater than 80. So my stack does not contain any elements lesser than 80. Okay, so how many elements are less than or equal to 80? Only 80. So I'm going to put in 80. Next comes 60, right? No, you know what? I will come to this approach, but let me teach the brute force approach. Okay, same thing. 100 I put in, but I don't include any other value. Now I see 80, 80 I put in. Now I see 60. Is any value less than 60? No. 60. 70. Is any value less than 70? Yes, there is a value less than 70. So what I do, I pop this out, okay, and then my count, when I pop this out, my count became 1, right? Okay, now when I pop this out, what will I do? I'll store it in another stack. This will be stack 2, right? So then what will I do? I will have my count. I'll add my wait, this answer was about 1, right? I'll have my count plus the current element is 2, right? Because the count I've gotten is 1 plus the current element is 2, right? So I'll append 2 to the answer. I'll pop it out of stack 2, then I'll pop in 70. Now I found 60 again, right? It's not. So what I do is I push 60. When I get 71, what I do is I pop this out. I pop this out. Okay, now the count is what? Count has become 3 because 3 elements have been popped out. What I'll do, 3 plus I have to include this element as well, so it become 4, right? Now what will I do? I will pop it back in again, right? I'll take the same, now take it out and I put it back. Okay, perfect, right? Now I have to put 75 as well. Okay, I found 85. Great. Again what I do, I pop this entire thing out, take it out, I put it on my stack, right? My count will become 5 plus 1, I have to include 6. Perfect. Then what I do, I need to wait. I pop this out, put this in the stack, then I push in 5 plus 6, 1, this one, right? And then what I'm gonna do is I'm gonna pop this back in, okay, and then I'm going to add 85 as well. Okay, now this This is good, looks good, our approach looks good. What are we doing? And when we find an element, we are popping out all the elements less than that element, and then we are popping it back in. Okay, right? What is the time complexity, right? And what is the worst case, right? So the worst case would be like if you have to at last, like you have, like, 10 power 4 record. The last record is the one which is greater than all the values, right? So what will you do? You'll pop out all the values, that is 10 power 4 minus 1 values you'll pop out. I'm saying there are 10 power 4 records in your stack, right? The 10 power 4th record is the one which is greater than all the elements. So what will you do? You'll pop out all the elements, you'll take 10 power 3 elements, put it on the stack. Then you will add that, then you will pop everything back to the stack again, right? So what would be a time complexity, right? If you think about it, what would be a time complexity? uh, this was my initial approach, so let us go to this approach actually, right? If you see this approach, what is my time complexity? It was a lot, right? So I was popping out of the stack, right? And then I was popping it out of the stack, and then I'm going to the other stack, right? And then I am trying to add that value back to the stack, right? So this, if you think about it, it'll take us a lot of time, okay? And we need to optimize this. Right? How do we optimize this? Let's think about it. Okay, let's come to the time and space complexity of this approach. But we know that when the 10 power 4 element, the 10 power 4th element is greater than all the 10 power 4 minus 1 elements, it has to pop out 10 power 4 minus 1 elements, take the count, and then add it up, right? Now, what are we doing? If you think about it, what exactly are we doing here, right? If you see, we have 100, we have 80, we have 60, we have 70, we have 60, we have 75, we have 85. Okay, now what I'm saying is, see, for 75 what I'm doing, I'm popping out 60, calculating 80. For 75 what I'm doing, popping out 60, popping out 70, popping out 60, calculating. For 85 what I'm doing, popping out 75, 60, 70, 60, right? So do you see any repetitive work, right? Do you see any repetitive work? Yes. Why? Because if I have to find for 80, I'm popping out 75, 60, 70, 60. Okay, but if you see, I've already done that operation for 75. That is, I popped out 75, 60, 70, and 60, right? So all I had to do is pop out 80. That is only addition 1, right? If you take 75, smaller than 75 is 75, 60, 70, 60. Okay, this I'll do it for 75. Now for 85 also I'll do the same thing, right? I'll have to pop out 75, 60, 70, 60. Only then I can go to 80, right? So this is a repetitive work, right? So we need to figure out a way in which we can reduce this repetitive work, right? A way in which we can directly reach this 80. We can have a count and append this count saying 1, 2, 3, 4, 4, and then directly reach to 80, and then add 1, and then add 1 for 85, and then return 6. This is what we need to do. Okay, how do we do it? Let's see. What I'm saying is, this is my let's say this is my stack. Okay, so I call it as stack, right? And then I call it as the span, right? Now what will I be doing? It's very simple, right? I put in 100 to my stack, the same approach, right? I'll put in 100 into my stack. Okay, I put 100. What is the span of 100? 1. Okay, Now I put in 80. Is 100 less than 80? No. So I have 80, the span of 1. Okay. Now I've put in now 60. No, it's not. So I put in 60 with the span of 1. Okay. Now I have 70. Okay. 70 is 70 is greater than 60. That close by one of the stack. Okay. I will pop this out of the stack. I'll have a count variable which will take this count, that is 1. Okay. I'll pop this element. I don't need this element anymore. I'll remove this. I'll remove this element. I don't need this element anymore. Right? Now what will I do? My count is 1, meaning that there is one element lesser than 70. Then I check 80. Okay, it's not. Perfect. Now what do I have to do? I have to add count plus 70, right? Because I have to include that element as well. So what I do, I take 70 and I put in 2. Perfect. Okay. Next I go to 60. Is the element less? No, it's not. I go to 60, I put in 1. Okay. Now 75. Is there any element lesser than 75? Yes. That is 60. The span of that is 1, meaning that it's coming once. Right? So what do I do? What do? I remove the 60, okay, and then my count will be set back to count will be set back to count will be set back to 0 before starting. Now I've taken out the span of 60, so my count will become 1, right? Then I go to 70. Okay, 70 less than 75? Yes, it is. What is the span of 70? Meaning that how many elements are less than 70? There are 2 elements less than 70, less than or equal to 70. There are 2 elements less than or equal to 70. What is that? One was 60, one was 70. I'm saying less than or equal to. Okay. So I have to. If the element is less than or equal to 70, definitely the element will be less than or equal to 75. Right? Okay, so now what I do is I make this count as plus 1, 2, just 3. Okay. Then what I do is I pop this out. I don't need this, right? I don't need this, right? I pop this out. Okay. Now come to 80. Is 75 greater than 80? No. I mean, no, it's not, right? So what I do, I have my count. I'll just push 75 and my count as 3. Perfect. Now I come to 85. Okay. Now I come to 85. Now I need to figure out the elements less than or equal to 85. Okay. Now 75 is less than 85. So what I do, the same thing. I have my count which will be 0 initially. I will pop this out. I'll pop this out. Wait. Pop this out. And then I will have my count as 3. Count as 3. Okay. Is 80 less than 85? Yes, 80 is less than 85. So what I do is, again, I pop this out, take it out, I'll leave it. Okay. Span of 80, how many elements are less than or equal to 80? It's on one element. Right. So what I do is increment my count. So plus 1 equals to 4. Now what I do is 3. Now what I do is 4 6, right? Oh, sorry, 75 was 4. 3, right? I have included 3. Is 4, right? So count is 4. 4 plus 1, count is 5. Okay, now what I do, 5, it's 100, no it's not, 100 is not less than 85, so what I do is I push 80 with 6, so I return 6, I push 80 with 6. Perfect. So I hope you understood the solution. Let's try to code it up. Okay, so what am I going to do? This stack and span, I can have it as 2 different stacks. You know what, let me have it as 2 different stacks only, or let me have it as a pair. That's more interesting. Declare a pair. Perfect. Declared pair. Now let me use that pair. Okay. So what I'll do is I'll have a stack of pair. I'm calling my stack equals to new stack of. Perfect. Now what I'm doing is what's wrong with this? Okay, perfect. Now what do? I'm next, right? Next is where I have to return the element, right? So I'll simply say if my stack dot size equals to 0, my stack dot push price with a span of 1. I'm gonna return 1, right? Perfect. That's right. I have int count is 0. Okay, while my stack dot size is not equal to 0 and my stack dot peak dot get key is nothing but the number, and value is nothing but the span. Get key is my span dot peak dot get key less than or equal to price. My stack. So what I'm gonna do is var I'm gonna call it temp val equals to my count plus equals to temp val dot get value, right? Perfect. Gotten the value. Now I've gotten the value. Now what do I have to do? I have to push. So what I'm gonna do is my stack dot push of new pair of get key is what? My price, and my value is what? Count plus 1. Why count plus 1? Because I have to include that element, right? Count plus 1. Okay, peace. I pushed. Now what do I have to return? Count plus 1. So I've added it to my stack. Now I have to return count plus 1. Perfect. Okay, I think we're done. Let's see how it runs, and let's validate. Okay. Sorry. Perfect. Let's submit it. Okay. Perfect. Okay. Last time I had 85 cases pass through, but some it failed. Now I have 99 cases passing. What is my time complexity? It's O of 1 into F. O of 1 for each next operation, right? So it is nothing but O of 1 itself, right? The one that I had gotten was O of n, right? But I think because of this large computations, it threw me an error. But if you see over here, this is O of 1, right? So what does it say? O of 1 for each next operation. Perfect. Okay. I hope you understood the solution. I would suggest you to do the same and try to come up with the approach. Okay. Thank you so much for watching.